Okay, so I noticed several people also commented that, they weren't sure if they had been doing the homework correctly or not, like assignment 5 and then, maybe probably even assignment 6, um, which was, you turned in this past Monday. Um, and so what I'm going to do here, and I can't promise I'll be able to keep up with this every single week right on time, but I'm going to do my best here to give you some solutions here, so that you can feel more confident about what you're doing and see, is this what you did, or are these the dimensions you got, as far as knowing whether or not you did it correctly. So let's first go ahead and dive into here. So let me first um, do this here. Okay, so I've split this here. So assignment 5, problem 1 here. Let's recreate the pad stack for the dip package, the one discussed in the videos. So um, let me first pull open my pad stack editor and pull open this. So I know it's in the video, but I'm just going to go back through the data sheet to get to it. So we just talked about doing it, so I'm going to go to my mechanical drawings. Okay. And first thing we need to do is we need to determine my hole size for this. So let's go to Onenote here. We're going to kind of go back and forth here. So we need to know what is my minimum hole size. And to do that, we need to find the diameter of the pin. Now remember, if you have a rectangular pin here, which is really what we have, this diameter that we need to find is the diagonal here. So we need to find that diagonal. And so let's go back to the data sheet and look at the dimensions here. I knew that was going to happen. So we're going to be in millimeters again. That's what we're going to use. 0.53 millimeters because we're going to use the maximum when we have the max and the min here. So 0.53 millimeters wide. And then if I go, do I have to find, I have to look here. Oh, here it is. 0.25 millimeters for the other direction. So what that means here is we've got 0.53 millimeters, and I already forgot 0.25 millimeters. And we want to figure out this d. Well, simple Pythagorean theorem gives me that d is equal to the square root 0.53 squared plus 2.5 squared. So let me bring up a calculator. So I did 0.53 times 0.53 plus 0.25. Whoops, of course I did it wrong here. I hit the plus. I hate it when I do this. 0.53 times 0.53 plus 0.25 times 0.25. And I know I could have used my square key, which would have probably made more sense. Square root of that, 0.586. Millimeters. Now, Some of you I noticed, and I maybe should have suggested this more, is that when you're watching the videos, it's a good idea to take notes because it's definitely, first time using this stuff, it's going to take you a while to get used to it. And I don't even remember. I'm going to have to slide back in my notes here, go way back here. Not for the pad size because that had a mistake there. Minimum hole size. Remember, we're going to be doing level A, so it's my diameter plus 0.25. So let's scroll all the way back to the bottom here. And I just feel like I did something wrong there for a second. Yeah, 0.25. So my minimum hole size is 0.586 plus 0.25, which is 0.836 millimeters. And now that's again the diameter. And we remember talked about the fact that we only have drill bits that go in tenths of a millimeter. Now, I said we should always round up. Now, technically, we could probably get away with just rounding down to 0.8 and we'd probably be fine. We're still going to go ahead and use the 0.9. But if you got like 0.0 or 0.801 as your diameter, I would not round up to 0.9. I mean, 0.801, I mean, come on, that's basically 0.8. But at 0.836, I'm like, yeah, I'm going to round it up, you know. But again, you could probably round this down and you'd be safe because the reality is you're talking about, and instead of doing 0.25, you'd be doing 0.22 is what you've been adding on for it because you're never going to be able to be exact. Now, if you want to make certain that you absolutely meet what the minimum requirements are for level A, then you should technically always round up. But I've never seen a company where they're that, technical where, oh, we better round up. Okay. So we've got my minimum hole size. Now, panning, we get to move on to the pad size. And we're going to do circular pad. We did talk about in another video, I talked about why you want a circular or a square pad, but we're going to do circular. And for level A, if I could spell level correctly, it is the minimum hole size plus 0.1 millimeters plus 0.6 millimeters. Now, it sounds a little weird, like why I wrote that as 0.1 and plus 0.6. That's the reference I was using, and it has to do with it. You're satisfying two different pieces of information in the IPC standards. So, I mean, you could think of it, as adding 0.1 and 0.6, but you could also clearly think of it as just simply adding 0.7 millimeters, because obviously that's what you're doing. Okay, so hopefully this is not too difficult for us. So we have the pad size is equal to, well, my minimum hole size is 0.9 millimeters plus 0.7 millimeters, which is 1.6 millimeters. I'm going to do a little bit more calculation, and then we'll be able to make this pad stack. And now the other calculation I'm going to do is say, okay, well, I want to add a solder mask. And it's 0.07 millimeters, and I forget to write the extra M there, all around. This means we add 0.14 millimeters to the pad size. So let's talk about that a second here. I think some people got confused on that. So I've got my hole that I drilled. I have the copper pad that was then etched around it. And now I'm trying to do the solder mask opening. And obviously this is not going to be to scale, and it's not perfectly circular either. But what it is saying is that this distance here that I'm just shading here, I'm trying to draw an arrow and it's not going very well on my tablet here. That distance between the blue and green circle is 0.07 millimeters. But that means we're talking in diameters, not in radiuses. So if this is 0.07 millimeters, there would be also 0.07 millimeters there, which is why I end up adding 0.14 millimeters to the solder mask to the pad size for my solder mask. So my solder mask is going to be 1.6 millimeters plus 0.14 millimeters, which is equal to 1.74 millimeters. Now, we're going to enter all these in here, and I had a student that emailed me and they were concerned, and I'm aware of this, and I'll take this into account when grading, because I was unaware that the program did this, but I'm aware now that it does this, and I've confirmed that this is an issue. It has to do with the fact that Cadence is basically it does everything in inches, and so when you save in millimeters, it's quote loss of accuracy because it's doing a conversion back and forth. So I think it's still saving the data in inches, and so then when it's opening back up, it's converting the inches back into millimeters. And so that's where this loss of accuracy is coming from. We could do everything in inches, and actually some people do, but we're doing everything in millimeters in this course. So with that being said, you'll type in 1.74 millimeters, and the next time you open it up, or if you turn it in, I might only see 1.7 millimeters. It will, like, for instance, for some reason not save that 4 even though you entered it in. But sometimes it's there, and sometimes it's not. So it's kind of a quirky little thing, but I'm aware of that potential issue, and I'll be taking that into account when grading assignments moving forward. And if you feel that that was an issue in a previously graded assignment, please let me know and I can look at that assignment. So after all of that, just going to go to the pad stack editor, and I'm actually going to go like this here. Of course, it suddenly. Okay, so Pad stack, we're doing a through pin. Default geometry is circle. Millimeters, yes, I know. Loss of accuracy, continue. Decimal places, 4. So let's go ahead and do this here. Finish diameter, 0.9. Drill symbol, circle, 0.9. And that gets us that little black outline around the red circle. Design layers. Okay, geometry, circle. Diameter, well, we computed it to be 1.6 millimeters. These are the copper pads. Circle, 1.6. Circle, 1.6. We're not doing anything with thermal, anti, or keep out. Mask layer, solder mask, circle, and it was 1.74. Solder mask bottom, circle, 1.74. All right, so the pad stack's now done, and we can go ahead and click on save, which is what I'll do. And I'm in a directory that has a bunch of poorly named pad stacks, which actually, let me just go ahead and do something here. See if it, oh, it's not going to let me. I'm going to actually delete most of those just so that we don't have that in future videos here. Now, I'm going to do this again, naming it. The circle, my pad size is 1.6, so it's 160. And my hole size is 0.9, so it's 90. So C 160, H 90. And then I had been doing last name. As I was grading, you don't need to put your last name anymore if you do want to. If you don't want to, but if you want to, you can keep doing it. Now, I also heard someone make a comment about hard remembering all of the naming conventions. So I have posted these, but what I'm going to do is I'm going to make a spot on the website in our Blackboard site to make it easier to find these. I have a few of these memorized, but I don't have them all memorized. The only reason I have a few of them memorized is because, of course, I've been doing this a long time. But I don't have them all memorized. I'm going to save it. What I do, though, is I don't care that I don't have them memorized. I just go and I'm just taking us to our directory where I save everything here. And I use this PDF as a reference. And then it's got a bunch of examples here. And you see, and you know, they've got that 1.5 millimeter diameter and a hole of size of 0.9 kind of thing. And then, you know, via circular land, you know, a hole of 0.25, you know, so on and so on. You know, so they've got a bunch of examples as well as they give you the land shapes, you know, that you're used to dealing with. And so I literally would print this out, and it's not that many pages, 5 pages, you know, staple it together and just keep it with you at all times. Or in your notebook or whatever you use for this course, because then whenever you're having to then, you know, do a naming convention for something, you're not having to remember everything. You can just look up at the examples and then basically take an example here. For instance, if you're making a via, okay, well, you know, we're going to be doing very basic ones, you know, nothing quite as advanced as some of these. And so like, oh, look, here's an example of how to do a via. You know, and then, oh, here's an example how to do rectangular SMT, surface mount, you know, landing. This is if it was a square one as opposed to a rectangular one. You know, so I mean, it's showing, and these are all in millimeters. All these dimensions are in millimeters, so it's very helpful for us. And then remember, if you're wanting to do, instead of a via, a W would be for a mounting hole. And that would work the same as it would for this V here. If you're doing a mounting hole, it's the same thing. Okay, well, what's the hole, mounting hole? What's the size of the copper pad? Or maybe there, is no copper pad, but what's the size of the copper pad? What's the size of the hole? If there is no copper pad, you can just do VH and then put the size of the hole. Because if you have no number after, W, if you have no number after the W, that then is going to assume that the copper pad is 0. So you don't actually have to put W0, H, 3 or something, or 300, So I would use this to help with the naming conventions. So I'll end this one here, and I will go ahead and continue making this for the rest of the assignment, and we'll go from there.